Okay, here we go. First question. Now I may put you off because I want to do a group research on a question. So I may put you off because the question may be too general. All right, so, but I'm not like saying, no, I don't want to help you, you know. So I may put you off and we may do a group research on a topic to see if we can crack it, to get different points of view. We have, you know, 2 heads are better than 1, right? Well, 7 heads are better than 1, okay? So let's start with the questions. Yes, first, Eden.
So in Bohr's model, they're talking about the Planck equation.
The Planck equation in Bohr's model, correct?
And I understood like what things stood for in the equation, but there's a certain part where I got really confused where it says, yeah, like I understand that atoms can emit, like they emit photons, and then that emission, like those photons, they make the lines in frequency.
Yes.
But then I didn't understand where it says because the electron can only occupy certain orbits, and then the energy levels are thought of like a staircase. The electron cannot change its energy in a continuous way in the same way. Like it changes its energy by discrete amounts.
That's correct.
This energy of the atom is quantized.
That's right. Well, look up the word, before we begin, I'm going to take someone else's question first. Look up the word quantum and quanta. Just Eden, not you guys. Just Eden. Do a little quick research on that word. I think you may be having a problem with understanding Latin. No. I don't mean that. I'm not being mean. But look up the word in a dictionary, not a science dictionary, in a regular dictionary. Look up the word quantum, quanta. Quanta's plural. What is it? For what? No, just look at the word quanta. Just look up that word. All right, now, next question. What do we got? Yes? Yes? What is it? Isotope. Okay, good. That was the first question that when I walked in here. The word isotope and what does it mean? Okay, let's do that first. Okay, now. An isotope is simply this. It's a variation of an element based on the number of neutrons in the nucleus. Don't write that. Understand what I just said. Ling Ling's like writing it. Like, what did he say? Word for word? All right. In other words, it's a variation of an element. In other words, hydrogen has 3 isotopes. There's 3 types of hydrogen. Why are they all hydrogen? Because they all have 1 proton, right? But there are 3 hydrogens. Now, let me show you how to represent an element. Up here, you put the mass number, and down here, you put the atomic number. And that's hydrogen as we know it. Ling Ling.
But how do we know that there's 3 hydrogens?
I'm going to get into that, okay? I'm going to get into that, okay? Now, Ling Ling asked, how do we know there are 3 hydrogens? And I'm going to get into that. So this is hydrogen. This is called hydrogen 1. And this is how you make the symbol for hydrogen. The mass number goes on top, and the atomic number goes on the bottom. Superscript, subscript, yeah? So when you say hydrogen 1, you say hydrogen 1. Hydrogen 1, meaning that's how you say the isotope. If you have carbon 12, or you have, for age dating, for radioactivity, to find out how old a fossil is, you say carbon 14, okay? So that's the way you represent the symbol. That's a basic way of representing an element. Mass number, not atomic mass. That's actually the mass number of the isotope, okay? And then you have the atomic number. Clear? Okay, now. There are 3 isotopes of hydrogen, okay? This is what you call protium. That's just the name of it. We don't name isotopes generally. Hydrogen we do. This is called protium. Okay? Yes? we have this hydrogen, where you put in an extra neutron to the nucleus. Yes? There's an extra nucleus. So what would the mass number be of the next isotope? 2. So it's 2, 1. It's called hydrogen 2. It's called deuterium. Deuterium. Please forgive my spelling. Sometimes I'm a little dyslexic, not a lot, but sometimes my spelling suffers. It's okay. Okay. So deuterium. Yes, and then there's an artificial form of hydrogen. And we call that tritium. Tritium. Yeah, you want to say tritium, but it's tritium. Okay? The tritium. And it's called H3. Okay? And it's tritium. Tritium. Now, this doesn't occur in nature, but this does. Okay, you've heard of heavy water, heard the expression heavy water? No. No? Nuclear reactions and heavy water. Anyway, heavy water is just this, with hot water with that. This is water. Okay? 99% of all water, or something like that, is going to be that. Protium oxide. Right? You never see that. I'm just writing them down. You see sometimes this. Deuterium oxide. This is the same thing. Same thing. Okay? These are radioactive. This is not. Okay? This is radioactive. This is not. What's the difference between radioactive hydrogen and non-radioactive hydrogen? Chemically. What's the chemical difference?
Non-radioactive ones are more stable, I assume.
Absolutely nothing. The only difference between radioactive hydrogen and non-radioactive hydrogen is that radioactive hydrogen is radioactive and non-radioactive hydrogen is not radioactive. Chemically, they're the same thing. Protium oxide and deuterium oxide they both have identical chemical properties. They're the same.
So the difference
There is no difference.
There's no difference.
There is no difference. Yeah, it's physical, it's heavier. Okay. In a sense, you can say that it's heavier. But it's both the same properties. Okay? Now this is where atomic, can you see this? Where does this end on the left side? Here? Can you see that line? Yes? On the thing here? Can you see it? Let me see. Oh yeah, you can see it. Okay, just. Okay. So this is where atomic mass differs from mass number. This is mass number. Let's define mass number. Mass number is equal to the number of nucleons in the nucleus. What's a nucleon? Protons and neutrons, just the particles in the nucleus. Members of the nucleus are called nucleons. Okay? The number of nucleons, correct? Okay, so this is where it gets a little funky. Right? So let's pick a number that's more realistic, although we're going to make up this data completely fake. It's all right. We can do that. Okay. So let's say I have 1,000, I randomly select 1,000 molecules, 1,000 hydrogen atoms. Not molecules, let's make this simple. We'll say 1,000 hydrogen atoms. Okay? 1,000. Random. Okay, and I count them. I have a way of counting them. There is a way of counting them, by the way. It's called mass spectroscopy. We'll talk about it. It's on your IB. So let's say that 985 are H1. Okay? All right. What would the total... What's the total mass of 985 protium atoms of hydrogen?
985.
985. Right? Now let's say we have what, 15 left? Is that right? Let's say that 12 12 are deuterium. What's the total mass of 12 deuterium atoms? 24. And let's say, what's the balance? 3? 3 are tritium. You know, 3 got away. We now have a balance of 3 in the universe. 3, you know, 3 out of 1,000. So what's 3 tritiums? 9. Okay, good. What's that add up to?
It's more than 1,000.
1,018.
That's more than 1,000?
Yeah. When you add it all up.
No, it's 1,000, right?
No, that's 1,000, but the other.
Yeah, but it's okay, but that's okay. Isn't that okay? I'm saying there's 1,000 atoms of hydrogen, right?
But not the mass.
The mass is going to be,
Mass is different.
the mass is different, yeah. So what's this equal?
1,018.
1,018? Okay, you okay with that? Yeah? Yes or no?
Yes.
Yes. Okay, now, you ready? This is it. You ready? You ready? What's the average mass of one hydrogen?
1.
No. How do you get average? You remember how to get average?
Over 100?
Where-
Oh, over the
total mass divided by number of atoms.
Yeah. Right?
So it's
Legally, right? Yes. So isn't it going to be, can I write down here?
1,000.
Do I have to teach you how to do averages? Means? No? I'm a little worried. Should I be worried? I feel like I'm in a brain trauma recovery unit at a local hospital. Are you guys okay? You sure? Excellent. Okay. So it's going to be 1,018, the total mass, divided by 1,000. What does that equal?
1.018.
And that's going to be the mass. That's going to be the atomic mass. Atomic mass units. Correct? You see where those little decimals come from now? You get it? So an isotope is simply simply the same element. It's the variation based on the number of neutrons. That's all it is. And Ling Ling's like worried like she has to memorize them. No, you don't have to memorize them. What you do is you do something very unconventional these days. You look them up. Okay? You look them up. Or I'll give them to you. I'll give you the data. There was one on your papers. Wasn't there one on your papers finding the average mass of X number of hydrogen atoms with just protium and tritium? On your paper? I think there was one. I think I saw one. You may not have seen it. But anyway, that's it. That's the answer to your question. So that is a review of isotopes. Are there any questions? It's actually pretty thorough. That's actually not too bad in terms of, you know.
So if we find the atomic mass unit, we can identify how many isotopes are there.
Yeah, you have to, in order to calculate this yourself, you need this data. You need this data. You know, you need to be given some data. Or percentages or something. You need data in order to do this. So you need to look up, you need to find, you need to be given, like if say this was on the exam, like paper 2, you need to be given the data. All right, I have chlorine 35, chlorine 34, chlorine 36, whatever. And you have to be given the percentages. The percent abundances are, okay? I didn't do percent abundances, but you could. I could change these to percent abundances, couldn't I? Just out of 100, right? Right? Okay, but you have to be given some kind of data
To calculate the atomic.
in order to calculate this. And there are problems in the book. This is not, are you suggesting, Porcian, Chile, are you suggesting that this is difficult? No. No. So, and there are problems in the text that will help you review this. And you have to review it, because otherwise you'll forget it. It looks easy now, but you'll be doing it later on. You'll be like, nah, how do I do that? Okay? We're off.